7.3, and this will also be on our exam test, whatever you want to call it. And we are starting with what's called, they're going to ask you to state the excluded values. So what that means, and I'm going to give out piece of candy for this, so let me get it written down and pause. So an excluded value is when you're going to take our denominator, that is equal to 0. When you solve this, don't you add 7 to both sides? That's going to get you p equals 7. That is your excluded value. That's the number that this problem, if you put the 7 in here, you're going to make this equal 0. So p cannot equal 7. That is your excluded value. That's what they mean by the excluded value. Because some problems have numbers that can't be part of the answer, and some don't, but this one does. Number 2. So again, we're just going to look in the denominator, because we're looking for the excluded value. What's the number that we could put down here that would make our denominator equal 0? Daniel, what do you think? Yes, it would, because if you minus the 4 from both sides, you're going to get n equals negative 4. That, again, is your excluded value. That would be n cannot equal negative 4. If you put negative 4, if you solve whatever math and decide negative 4 was what you want to put in there, it would make the denominator 0. But getting a 0 in the denominator of a fraction is one of the worst things that could happen. If it has no value, it'd be undefined. We're going to change again, and we're still looking for the excluded values. I'm highlighting the denominator because it's the one that has to put, that's where the excluded values are going to be. Now, there's 2 ways you can solve this. It would be better if you think factoring. You can solve it by adding the 4 over and then taking the square root, but that is going to lend you to not getting both answers. This way, you're probably going to get both answers, because I'm going to put k here and k here. K here, what's going to go in these 2 spots? That's 2 and 2. And Lizzie, do you remember what the signs will be here? Yes, it will. So now, to finish solving this, Lindsay, do you remember what to do? What do I do with these 2? No, I get back to this if I multiply it. They're set equal to 0. What does that mean? Set equal to 0. You got to remember what that means. You set them equal to 0. Each one gets set equal to 0. So I'm going to minus 2 minus 2. That's one of your answers. Plus 2 plus 2. So this excluded values here are going to be k cannot equal negative 2 and k cannot equal 2. Those are the 2 answers that won't be allowed because both of those numbers would make a 0. Okay, so number 4. Again, we're still looking for excluded values. You need to know that the only place there are excluded values are in the denominator. Can anybody go ahead and tell us what the answer is before you actually solve it out? What would the numbers be, Michael? Right, they're going to be 5 and negative 5. But to actually prove that, we're going to put the equal 0, do our little factoring because we have to practice our factoring. Sarah, what are we going to get here? Excellent. That's the difference of 2 squares. Because x and x is x and x, that's x squared, right? And what's 5 times 5 is 25, yes? And if you add the 5 and subtract 5, isn't that 0? That's why there's nothing in the middle of this one. We're just checking it like it was a trinomial. This is the difference of 2 squares, x, 5, 5. So I'm going to x plus 5 that equals 0, x minus 5 equals 0. Solve both these little guys, and those are the 2 answers that Michael came up with. Those are your 2. So x cannot equal negative 5 and x cannot equal 5. Those are your excluded values. That's all we did. Okay. So we're going to do another one. Let's see, number 5. And we're still doing exclusions. Excluded values. Mark. Remember where you're looking. You're only looking down here in the denominator. Edgar, what am I going to do with this? Right, set it equal to 0 and factor. Glad you knew that. Okay, so Daniel, what do you think? How am I going to start it? Very good, because he knows that 6 times 3 makes 18, so he put a 6 in his 3. He also knows one of them is going to need to be negative to make this negative 18. So which one of these has to be negative to make a positive 3 when you add them? Daniel, you want to give it a guess? It's a 3 and a 6. One of them has to be positive, one has to be negative. You know which one, Daniel? Positive or negative? Yes? Because that would allow, if you add a positive 6, if you say 6 minus 3, 6 minus 3 does get you a positive 3. That's that positive 3 right there. So it works. We multiplied and got a negative, and we subtracted and got the positive 3. So you set those equal to 0, and those will be your two needed numbers. It can't be negative 6, and it can't be 3. I'm going to come over here and go, y cannot be negative 6, and y cannot be 3. That's just the exclusion. We're going to build on that. We're going to simplify this. For the 21 and the 28, Samantha, how's that going to get reduced? Over 4, because we're dividing them both by 7. Divide by 7. Divide by 7. That got us our 3 and our 4. What's going to happen to the b's, Kaylee? Yep, b over b is 1, so they're canceled out. And Ryan, what about our c's? Right, where is it? It's going to be on the bottom. So we're going to end up with a 3 on the top, and that's it. And on the bottom there's a 4, and there's a c. So that is your simplified answer. But now you've got to state the excluded values. So what would be the one number in the universe that the letter C cannot equal down here? You think, Jasmine? Well, if we multiply the negative 4 and a positive 4, we get negative 16, which is okay. So wait a minute, look at it, that's most people's first guess. What would be a number that we would put here that would make this 0? Yes, that's correct. Okay, so 0 times 4 would make it 0, so that's the only number that this fraction can't have on the bottom, and this C can't be 0. It could be a 1, a negative 7, a 53, whatever, but it can't be a 0. So that's your one excluded value. Number 7 is going to be very similar. And Michael, close here, what does the 12 and 24 do? All right, so that 12 goes into 12 once, and 12 goes into 24 twice. And what about our m's, Pedro? Right, the m left over here on the top. And what about our r's, Sarah? That's gone, and that's going to turn into 2. So we end up with an m here, nothing else, a 2, and an r squared.